Hello everyone. Welcome to my channel. Now there's the second question for today's Leetcode weekly challenge. So here in this question we are required to design a data structure. Now in this data structure, what are the requirements is that we are required to design this data structure, and in that data structure the thing is that we are required to keep track of the values and answer some queries regarding their frequency. So that's the thing which the data structure will do. Another pointers are that while implementing this frequency tracker class, what are the things we are required to do is here the frequency tracker. Here this will initialize the frequency tracker object with an empty array initially, and then void add in number, the function which is there. It will add the number to the data structure, and then void delete one in number. It will delete one occurrence of number from the data structure, and the data structure may contain number and basically may not contain number. And if it doesn't contain any number, then in that context we are just required to do nothing. That's the thing. And then bool has frequency and frequency. In this, it returns true. If there is a number in the data structure that occurs frequency number of times, otherwise it will return false. So that's the thing which is here. Now the thing is that we are given with a class and we are given with several functions. So in these functions, the first function which is there, which is this one, here we are just required to add one number into a data structure. Then here we are required to delete that number, and at the end we are required to return the frequency of a frequency. We are required to return true or false if that much frequency exists in our data structure. So this is the thing. Now comes the part. It means basically during the contest time, what I was doing was, see, if we are required to just uh, basically insert any number, we can insert in any data structure. But then comes the part what operations are being performed on this number is that we are also deleting that number. So in that context, we are required to get that number. And the least time complexity for getting that particular number would be order of one. That would be through hash map. So that's why rather than just using a vector, we can use a map also in this particular question. Basically, we can directly use unordered map in this particular question. Now comes the next part, this hash frequency. This hash frequency, in that context, we will be traversing that unordered map, right? So that we can check that if that frequency really exists or not. But the thing is that if we will, here we can clearly see that constraints which are being given to us. Means here if we see the constraints which are there, that there would be this much number of calls. So because of that thing, and even the frequency and the number could go up to 10 raised to power 5. So the thing is that if we will be traversing that map for just checking that if that much frequency really exists or not. So in that context, it can clearly give us TLE. So in that context, rather than just traversing that particular previous map, we can create one more map which will be storing the frequency of the occurrences which was there. Means whatever frequency was there, we can directly store in that new map. So we can directly use two maps here, and because of using those two maps, because of using those two maps, here the thing would be one map is being used for storing these numbers and deleting them, and the other map would be directly used for storing the frequency of the numbers and the deleted ones, whatever are there. So we can directly check in that map in order of one that does that frequency really exist or not. So this is the thing. So now let us go ahead with the coding part for the same, and then we'll discuss about the time complexity and space complexity. Space complexity, we can clearly see that it would be order of n only, but yeah, need to see for time complexity as well. So here, now we will be using two maps. One is the frequency map and the other one would be frequency of frequency map. And here we are using unordered map. So clearly the solution could easily go in order of n rather than n log n, because here sorting is not required. We are just required to use the hashing part of our unordered map, so that there is no TLE, and even we can easily delete our elements as per the required. So now the thing is, see, this part if we eliminate this part, if we, yeah, one minute, I just need to ease out the solution. That's why for time being I'm eliminating the part. And here also, see, if we would have been using just one map, so how it would be? We will be just directly inserting a number into the same and then deleting that number into the same. And for frequency part, we would be directly traversing that map. Right. Now comes the part that when we are using another map. So because of that part, here first thing is, see, whatever we are being inserting, right? Before that, we need to eliminate the previous frequency of that particular element. See, if that frequency has that frequency of x in the same, means it is greater than 0, right? So first we are eliminating that frequency from the same. See, if 2 is occurred 2 times, so its frequency would have been stored. But see, now if 2 occurs one more time, so this frequency is required to be eliminated and new frequency 3 is required to be inserted. And because of that thing, see, because of that thing, we are doing this part, and because of this thing, we are doing this part. So this is the thing which we are required to do when we are adding, and even for deleting as well, we are required to do the same. When we are deleting, so in that context, when we are deleting in that context, first we will be checking that if our frequency of x is greater than 0, that simply means that this particular element was earlier stored as well, right? So if it was earlier stored, then we are required to first decrease the frequency from our frequency of frequency, and then we are required to eliminate this particular element from our that map which was storing the frequency of which was storing the number and its frequency. Now at the end we will be adding up what is the new frequency which we acquired in the frequency of frequency unordered map. So this is the process which we will be doing here. Now comes the part that why we use this map. We use this map for this purpose only. If this particular frequency really exists, means basically if it is greater than 0, right? So that simply means that it exists and that we will be returning. So it will return true, else it will be returning directly false. So this is the thing which we are doing at this particular portion of time. So this was all for this particular question. Now comes the part for time complexity. Here we can clearly see that all the things are being done in order of one time. Here addition is also done in order of one, and here deletion is also done in order of one, and frequency is also checked in order of one, because it is just checking for that what is the value at that particular moment. So that's what is being done. And comes the part for the space complexity, so that is order of n, because we are using that unordered map. Basically two unordered maps are used, so that's the thing. Anything we spared. So this was all for this particular question. If you have any doubt, you could comment that down. And yeah, this was all.